Hello, I'm from Mr. Edwards' 7th period class. I'm sure all you guys know me. I'm Jordan. I did my special senses and formical on taste, but now just to let everyone know that this video is not going to be as cool as Hunter's. It's not going to have a dancing horse in it. I'm sorry, but the same information is going to be inside of it, so just stick with me as long as you guys can, okay? So what is taste? Taste is the sensation of flavor perceived in the mouth and or throat on contact with a substance. For example, an apple, pretzels, a lemon, broth, and medicine. All these examples are examples of the 5 categories of taste: sweet, sour, bitter, salty, and umami. What is generally categorized as taste is basically a bundle of different sensations. It is not only the qualities of taste perceived by the tongue, but also the smell, the texture, the temperature of a meal that are important. The coloring of a taste happens through the nose. Only after taste is combined with smell is a food's flavor produced. If the sense of smell is impaired by a stuffy nose, for instance, perception of taste is usually dulled as well. Like taste, our sense of smell is also closely linked to our emotions. This is because both senses are connected to the involutory nervous system. That is why a bad taste or odor can bring about vomiting or nausea. And flavors that are appetizing increase the production of saliva and gastric juices, making them truly satisfying. One of the 3 anatomical diagrams that I have printed out like this, and I'm sorry if you guys don't know what this is, but just bear with me. How do smell and taste work? Smell and taste belong to our chemical sensing systems, chemosensation. The complicated process of smelling and tasting begins when molecules released by the substances around us stimulate special nerve cells in the nose, mouth, or throat. These cells transmit messages to the brain where specific smells or tastes are identified. The olfactory cells are stimulated by the odors around us, for example, like the fragrance from a rose or the smell of bread baking. These nerve cells are found in a tiny patch of tissue high up on the nose, and they connect directly to the brain. The gustatory cells are clustered in the taste buds of the mouth and throat. They react to food or drink mixed with saliva. Many of the small bumps that can be seen on the tongue contain other taste buds. These surface cells send taste information to nearby nerve fibers, which send messages to the brain. Our body's ability to sense chemicals is another chemosensory mechanism that contributes to our senses of smell and taste. In this system, thousands of free nerve, ending especially on the moist surfaces of the eyes, nose, mouth, and throat, identify sensation like the sting of ammonia and coolness of menthol and the heat of a chili pepper. How does your sense of taste work? Your ability to taste comes from tiny molecules released when you chew, drink, or digest food. These molecules stimulate special sensory cells in the mouth and throat. These taste cells are gustatory cells. They are clustered within the taste buds of the tongue and roof of the mouth, and along the lining of the throat. Many of the small bumps on the tip of your tongue contain taste buds. At birth, you have about 10,000 taste buds, but after age 50, you may start to lose them. When the taste cells are stimulated, they send messages through 3 specialized taste nerve cells to the brain. Where specific tastes are identified, taste cells have receptors that respond to one at least 5 basic taste qualities: sweet, sour, bitter, salty, and umami. Umami, or savory, is the taste you get from the glutamate, which is found in chicken broth, meat extractions, and some cheeses. A common misconception is that taste cells that respond to a different taste are found in separate regions of the tongue. In humans, the different types of taste cells are scattered throughout the tongue. Taste quality is just one of the ways you experience a certain food. Another chemosensory mechanism, called the common chemical sense, involves thousands of nerve endings, especially on the moist surfaces of the eyes, nose, mouth, and throat. These nerve endings give rise to sensations such as the coolness of a mint and the burning irritation of chili peppers. Other specialized nerve creates the sensations of hot, cold, and texture. When you eat, the sensations from the 5 taste qualities together with the sensations from the common chemical sense and the sensations of heat, cold, and the texture combine with a food's aroma to produce a perception of flavor. It is the flavor that lets you know whether you're eating a pear or an apple. The peripherogustatory or taste organs consist of certain modified epithelial cells arranged in the flat-shaped groups termed the gustatory caliculi, which are found on the tongue and adjacent parts. They occupy nest in the stratified epithelial and are present in large numbers on the sides of the papillary veillatae, and to a less extent on those opposed walls. They are also found on the fungiform papillae, over the back part, on the sides of the tongue, and in general epithelial covering of the same areas. They are very plentiful over the fimbriae and are also present on the under surface of the soft palatate and on the posterior surface of all the epiglottis. I am so sorry. I didn't know half of those words that were in there. Taste buds are the true taste organ. They have numerous sensory cells that are in turn connected to many different nerve fibers. Each taste bud has between 10 to 50 sensory cells. These cells form a capsule that is shaped like a flower, bud, or an orange. At the tip of this capsule, there is a pore that works as a fluid-filled funnel. This funnel contains thin, finger-shaped sensory cell extensions, which are called taste hairs. Proteins on the surface bind chemicals to the cell for tasting. The taste buds are located in the walls and grooves of the papilla. Adults have between 2,000 to 4,000 taste buds in total. The sensory cells in the taste buds are renewed once a week. Most of the taste buds are on the tongue, but there are also cells that detect taste elsewhere inside the oral cavity, in the back of the throat, epiglottis, the nasal cavity, and even in the upper part of the esophagus. Infants and young children also have sensory cells on their hard palatate, in the middle of their tongue, as well as in the mucous membrane of their lips and cheeks. The final step in perceiving taste is the transfer to the nervous system. This is done by several cranial nerves. All information is carried along the cranial nerves to the part of the lower section of the brainstem, which is the medulla oblongata. At that point, there is a split. Some fibers carry taste signals together with signals from other sensory perceptions, like pain, temperature, or touch, through several exchanges. The other fibers pass over these exchange points or consciousness perception and leading directly to the parts of the brain that are connected with sensory perceptions and which are responsible for our survival. It is here that taste signals are combined with different smell signals. It starts at the tongue. But what is taste actually? What happens in our body that enables us to perceive flavor? The chemical substance responsible for taste is freed in the mouth and comes into contact with a nerve cell. It activates the cell by changing specific proteins in the wall of the sensory cell. This change causes the sensory cell to transmit messenger substances, which in turn activate further nerve cells. These nerve cells then pass information for particularly perceptions of flavor on the brain. The nervous wart-like bumps on the mucous membrane of the tongue are where the substance producing the taste is transformed into a nerve signal. These bumps, which are called taste papilla, contain many sensory cells with a special structure. Together with other cells, they make up a bud that looks a bit like an orange, with its sections arranged around the center. In the middle of the top side is a small indentation filled with fluid. The chemical substance responsible for the taste are washed into the funnel like hollow. This makes sure that the substances are detected and analyzed by as many sensory cells as possible before being swallowed. What are taste disorders? The most common taste disorder is a phantom taste perception, a lingering, often unpleasant taste even though there is nothing in your mouth. People can also experience a reduced ability to taste sweet, sour, bitter, salty, and umami, a condition called hypoagusia. Some people can't detect any taste at all, which is a disorder called ageusia. True taste loss, however, is rare. Most often, people are experiencing a loss of smell instead of loss of taste. In other disorders of chemical sense, an odor or taste or a flavor may be distorted. Dysageusia is a condition in which a foul... Can you see it? Oh my gosh, you guys can see it. My lord, I'm so sorry, guys. I'm sorry. Okay. Dysageusia is a condition in which a foul, salty, rancid, or metallic taste sensation persists in the mouth. Dysageusia is sometimes occupied by burning mouth syndrome, a condition in which a persons experience a painful burning sensation in the mouth. Although are taste disorders diagnosed? Both taste and smell disorders are diagnosed by a
otolaryngologist,
a doctor of the ear, nose, throat, head, and neck, an
otolaryngologist
can determine the extent of your taste disorder by measuring the lowest concentration of taste quality that you can detect or recognize. You may be asked to compare the taste of different substances or to note how the intensity of taste grows when the substance's concentration is increased. Scientists have developed taste tests in which the patient responds to different chemical concentrations. This may involve a simple sip, spit, rinse test, or chemicals may be applied directly to specific areas of the tongue. An accurate assessment of your taste loss will include, among other things, a physical examination of your ears, nose, throat, and a dental examination and assessment of oral hygiene. A review of your health history and taste test supervised by a healthcare professional is provided. Can these disorders be treated? Diagnosed by a
otolaryngologist
is important to identify and treat the underlying cause of your disorder. If a certain medication is the cause, stopping or changing your medicine may help eliminate the problem. However, that does not mean that you should stop taking your medicine unless a doctor says so. Often the problem and the correction of a general medical problem can correct the loss of taste. For example, people who lose their sense of taste because of respiratory infections or allergies may regain it when the condition is resolved. Occasionally, a person may recover his or her sense of taste spontaneously. Proper oral hygiene is important to regaining and maintaining a well-functioning system of taste. If your taste disorder can be successfully treated, counseling may help you adjust to your problem. Taste is very important for humans, no matter if you're a little baby or a grown adult. Taste was a sense that aided us in testing the foods that we were eating, so therefore it was a matter of survival. A bitter or sour taste was an indication of a poisonous inedible plant, or water, or anything else we were consuming. The taste sweet and salty, on the other hand, are often signs of food rich in nutrients. As we grow older, like all the other cells in the body, those special sensory cells that make up the taste buds eventually start to wear out. As we age, the taste buds begin to disappear from the sides and the roof of our mouth, leaving taste buds mostly on our tongue. The remaining taste buds eventually become less sensitive. Smoking and eating scalding liquids can damage them further. Our sense of smell also decreases as we get older, and smell and taste are intimately linked. You should not ignore a decreased sense of taste. Diminishing taste and smell can lead to decreased appetite and poor nutrition because eating may lose some of its appeal. To compensate, people may add extra salt or sugar to their food, which can lead to problems for those who have high blood pressure or diabetes.